Welcome to Stats Rescue 911. My name is Lynn, and I am going to show you how to conduct and interpret a two-way mixed ANOVA. So let's start with a little bit of a warning. In order for you to really get the most out of this video, there are certain things that you need to know. For example, between versus within subjects factor. You need to know the difference between those two different types of factors. Factor, of course, is another word for an independent variable. You also need to know how to enter factors into SPSS. And of course, how you enter those factors depends on whether that factor is between or within subjects. You need to know how to enter your dependent variables into SPSS, that is your data. Main effects versus interaction effects, marginal means versus cell means, post-hoc tests, y-error bars, and confidence intervals. So as you can see, there's a lot that you need to know before you can really effectively conduct and interpret a two-way mixed ANOVA. If you don't know what these terms refer to, then I suggest that you look at my other videos, which will define and give examples and show you how to do, what you need to do in order to perform the two-way mixed ANOVA. All right, so let's go ahead and look at the setup for the example that I'm going to run you through today. We have two factors here. This was a survey. I should start by saying this was a survey that I gave students. I wanted to know whether or not their preference for horror movies, that is whether they loved them, liked them, or hated them, had any effect on fear, their fear scores. But I also wanted to look at their fear during the day and fear during the night. So I had the two factors. The first factor that I mentioned was the horror movie preference. This was between subjects, love, like, and hate. And then I had the second factor was within subjects factor, and that was fear during the daytime and fear during the nighttime. That left me with these 6 treatment combinations. And we're going to go ahead, we're going to look at whether there's a main effect of horror movie preference on fear scores. We're going to look for a main effect of time on fear scores, that is, does day versus night matter? And then we're going to look at the combined effect of the two factors. Again, this is a two-way mixed ANOVA because we have two factors, and one of those factors is between subjects, and the other factor is within subjects. So let's go ahead. We're going to go to the SPSS file. As you can see, I've already got my variables entered, and I have my data entered as well. So we're all set to go. The two factors we're analyzing are horror movie preference, the between subjects factor, whether you love, like, or hate horror movies. And the second factor within subjects was day versus night fear. And then these are all their fear scores. All right, so to get to the two-way mixed ANOVA, you go to Analyse, and then go down to where it says General Linear Model. Don't go to the one underneath. And then go to where it says Repeated Measures. We're going to rename the within subjects factor. Remember, that was the time which they reported their fear scores, that is day versus night. There were 2 levels, so we'll go ahead, we'll enter 2, hit add. Now we need to define those levels. So you click on define, and our 2 levels were day and night. All right. Now, the between subjects factor was horror movie preference. So you move that to where it says between subjects. And now we have to look at all of these options. I always like to get a graph of the means, so I clicked on plots. And I have to move one variable over to the horizontal axis and one as separate lines. I tell my students that the variable that goes on the horizontal axis, it should be the primary factor that you're interested in. And I think in this case, we were most interested in whether there was a difference between day fear scores and night fear scores. We predicted that there would be, but we have to test that, so hence the survey. We're going to move time over to the horizontal axis. Now, the other variable, horror, we wanted to see not only if time of day mattered in terms of fear, day versus night, but whether that would depend on whether you love, like, or hate horror movies. So horror, in some respects, then, is the moderating variable, the variable that interacts, we think, with time to have an effect on fear. So horror is the secondary variable, the moderator variable. We're going to move it over here to where it says separate lines. Now we have click add. And then as far as the chart type, I'm going to ask for a bar graph. I want Y error bars on the graph, and I'm going to choose the 95% confidence interval. Hit continue. You can see why some background information is necessary here, as I'm not going into detail about Y error bars and what they are and whatnot. All right, the next thing, post hoc tests. Here, if we do have a main effect of horror, we're going to need to run post hoc tests to see which means are different from which. Horror has 3 levels, so we're going to have 3 means. So if it's significant, we won't know which mean is different from which. That's what the post hoc tests are for. So we're going to move horror over. Now, just as a reminder, if, let's say, the horror factor, your between subjects factor, only had 2 levels, you would not need a post hoc test. All right. We now tell SPSS which tests we want as far as the post hocs. And we want LSDT. That was very smart. SPSS, very funny, left off the T. Let's see, Chaffee and Tukey. And click continue. All right, now those are the post hoc tests for the between subjects factor. But we still would want to know how to get the post hoc test for the within subjects factor. To do that, I know this seems a little weird, but you go to EM means, estimated marginal means. Now, typically, estimated marginal means are not calculated for a two-way mixed ANOVA. These are more relevant if you do something called ANCOVA, which is another video. But this is where you need to go if you do want the post hoc test for a within subjects factor. Our within subjects factor is time. Now, normally we would not do the post hoc test because time only has 2 levels. But I'm showing this to you in the event that for your data set, your within subjects factor might have 3 or 4, etc. levels. So you got to know how to do it. So I'm going to move time over. And then this compare main effects, that's going to give you your post hoc test. I know it's strange. And then the default is probably going to work for most everybody, so we'll just leave that alone. Now hit continue. Next, go to options and select descriptives, estimates of effect size, and homogeneity tests. This will test the assumption of homogeneity of variance. Everything else is probably more than what you need, so we'll just leave it as is. Hit continue, and now hold your breath, hit OK. All right, good thing SPSS is fast, all I could say. All right, so I'm going to take you through the various boxes, those tables, those you need to look at. I do like to look at these first 2 because they just confirm that I set it up correctly. So I can see that I've got 2 levels of my within subjects factor, and that is time, day fear, night fear, so that's correct. My between subjects factor is horror for horror movie preference, love, like, hate. That's correct. And I can see that I have approximately equal group sizes here, ranging from 18 to 21. Next is the descriptive statistics box. And in here, I can see my cell means. All right, so the mean for love day, like day, hate day. This is the marginal mean. This is where it says total. That's the marginal mean for fear in the daytime. Here are my cell means for the night. So my love night, like night, and hate night. And this is the marginal mean for my fear during the night. All right, so again, I'm going to assume that you know what cell means and marginal means are. And once again, if you don't, check out my other videos. All right, I do want to just point one more thing out here in this descriptive statistics box. Notice that it does not give us the marginal means for the different levels of the horror factor. That is, we do not know the mean fear score for love, like, and hate. We only know the cell means and the marginal means for fear. So that's a little bit of an annoyance, a bit of a hassle here not to have that data, that the marginal means for the between subjects factor. In another video, I'll show you how to get that out of SPSS. And just in case you need to know all the cell means and both marginal means, that is the marginal means for both factors, I'll show you how. All right, this next test we can ignore. I'll just scroll on through here. We don't need this either. We're going to go to where it says Mauchly's test of sphericity. So this is an assumption that gets tested with the within subjects factor, but only if the within subjects factor has 3 or more levels. In our case, our within subjects factor time only had 2 levels, so it did not get tested. If you had a within subjects factor with 3 or more levels, then you would see a value here where it says sig. And you really do want this value to be less than 0.05. Sorry, just testing you. You don't want this value to be less than 0.05. Pardon me. You do not want this test to be significant. So if it is less than 0.05, that's telling you you have a significant test of sphericity, which means you have a violation. Anytime an assumption gets tested where it's significant, it means you have a violation. So not to fear, there is a correction that you're going to use for to account for the fact that you have a violation in sphericity, and I'll show you that in just a second. All right, the next table we're going to look at is the actual ANOVA results. Here, where it says test of within subjects effects, you're going to get the ANOVA results for the main effect of time and the interaction between time and horror. All right, now, because in this particular data set, we did not have to worry about sphericity. Remember that there were only 2 levels of time. We look at sphericity assumed. That's where we're going to pull our data. So here, for the interaction and for the error term, we look at sphericity assumed. But let's pretend that you had a within subjects factor and that factor had 3 or more levels. And let's pretend that the Mauchly's test was significant. So you have a violation. Then when you look at the main effect of time, you're going to look at this row of data where it says greenhouse geyser. Same thing for your interaction. You look at greenhouse geyser data. So all this row. And then for your error term, again, look at greenhouse geyser. All right, so looking at the main effect of time, sphericity assumed, we see that we have 1 degree of freedom, and we need to know the degrees of freedom for error. That was my dog in the background, Suki. So if we look at the error term, we have 55 degrees of freedom. So 1 and 55 degrees of freedom. Then the F value is 200.06, which is huge. We look over here at the sig value. In case you don't know, the sig value in SPSS is the same thing as the p-value, which is the probability of making a type 1 error if we reject HO. And we see that the sig value is less than 0.05, so we do in fact have a significant main effective time. Over here, partial eta squared, that's a measure of effect size. Partial eta squared can go anywhere between 0 and 1. The closer it is to 1, the greater the effect size. And by industry standards, a partial eta squared of 0.784 would be huge. So it essentially means that the main effective time is accounting for over 78% of the variance or the variability in fear scores. That's a lot. It's explaining a lot of what's going on with the fear scores. All right, for the interaction effect, again, we look at sphericity assumed in our case. We have 2, and then we go down to the error term, 55. So we have 2 and 55 degrees of freedom. Our F value is 28.19. Sig value, again, less than 0.05. We've got a significant interaction effect. The partial eta squared effect size is, again, very, very large. We're accounting, through the interaction, we're accounting for over 50% of the variability in the fear scores. All right, now we still don't know about the main effect of horror, our between subjects factor. So I'm going to show you where to find that. We're going to skip this box. Before we look at the main effect of horror, we're going to check and make sure that we do not have a violation to the assumption called homogeneity of variance. That is tested with Levine. Levine's test is done on the between subjects factor. HOV, homogeneity of variance, is an assumption that only applies to the between subjects factor. So here we're going to have to test for HOV twice. We have to make sure that it's satisfied for the day and for the night. And if we look at the results of the day, we will look at the this row here where it says based on mean. If you're using an earlier version of SPSS, it won't give you all these options. It'll just give you the Levine's test. It'll just give you one number, and it's based on mean. So we're going to look at Levine's 8.38, which is very large. I'm a little worried here. I look over at my sig value and it's less than 0.05. So we do have a significant Levine's test, which means that our assumption is violated. So we have a bit of an issue here. We'll come back to that in a minute. Let's see if it's violated for the night. So again, we look at based on mean. The Levine statistic is even larger. And no surprise, it is also significant. So we do not have homogeneity of variance for the day, and we don't have it for the night. Now, what I advise people to do at this point is to voluntarily make it harder for you to find a significant main effect of your between subjects factor. So in this case, it's horror. So I am going to make it harder for myself to find a main effect of horror. Instead of saying that something is significant at p less than 0.05 or sig less than 0.05, I am going to change that and I'm going to say it needs to be less than 0.03 or maybe even 0.01. All right, I'm making it harder for me to reject HO. I'm trying to avoid that type 1 error. All right, this next box is the result of the ANOVA, the two-way mixed ANOVA, the between subjects effect. And we look over here. Here is our between subjects factor. It's horror. And it has 2 and 55 degrees of freedom. The F value is 30.20, which is extremely large again. It is significant. And the effect size is also very, very large. Here we can see that the main effect of horror accounts for over 52% of the variability in fear scores. So it's explaining a lot of what's going on there with fear. It also means that main effect of horror is having a big influence, therefore, on fear scores. All right, now, just to summarize, so far we have found that the main effect of time is significant, the main effect of horror is significant, and the interaction between them is significant. Now, let's assume that the main effect, let's assume that the interaction effect was not significant, okay, not significant. Then we would want to follow up on any of the significant main effects. So we did find a main effect of time. We found a main effect of horror. What we mean by following up is we want to, if necessary, look at post-hoc tests to tell us which means are different from which. All right? Now I'm going to do that, but I need to remind you that we did find a significant interaction effect. Now, when you find a significant interaction effect, in many ways, that makes the main effects a little obsolete. That is, we want to report that they were significant, but we're not going to follow up with post-hoc tests. We're not going to talk about them because the interaction between them is significant, and that means that we're going to get more information by looking at the interaction effect than if we were to look at the main effects separately. Now, I don't know if that makes a lot of sense to you, but again, by convention, the rule is if you have a significant main effect, follow it up only if your interaction effect is not significant. If your interaction effect is significant, then report that the main effects are significant and move on. Just focus on your interaction effect. Okay, that's it. Let's go down to here where it says pairwise comparisons. This, although it's not obvious, this is the post-hoc test for your within subjects factor. Now, our within subjects factor was time. Remember, time had 2 levels. You would not normally, even if it's significant, you would not normally do a post-hoc test when you just have 2 means to compare. But just so that you know where to go, it's here in case you do have 3 or more levels. And so you would look here. This says 1 and 2. So 1 was day, 2 is night. And you would look, okay, 1 versus 2, follow the row till you get to the sig value, and it's significant, which means that there is a significant difference between day and night. You would look at your means to then tell people the direction of the difference. So you would say that people reported significantly higher fear scores during the night than they did during the day. There's no point looking at this next row because it's just looking at the difference between fear and day, which is the same as looking at the difference between day and fear. All right. Okay, so the next place we want to go, I'm going to scroll down till we get to here. Multiple comparisons, and then you see the results of Tukey, Chaffee, LSDT. These are the results of the post-hoc tests for the between subjects factor. Now our between subjects factor, which was horror, was significant. Normally that means we look at these post-hoc tests. But because the interaction effect was significant, we are not going to follow up by looking at these and reporting them. except I will show you how to do it in case your interaction effect is not significant. All right, so we look at Tukey first, and by the way, I'm going to show you how to interpret Tukey, and then the method is identical for Chaffee and LSDT. So if you know how to do one, you know how to do the others. So let's look at Tukey, and we want to know, is there a significant difference between love and like? So we go along the row until we get to the sig value, and we see yes, there is a significant difference between love and like. We would then look at the means for those two groups, and we would report the direction of the difference. So we would say that people who love horror movies reported significantly more fear than people who just like horror movies. Then we look at love versus hate. We want to know if those two means are different. We scroll over here until we get to the sig value, and we see that there is no significant difference between them. So that says, regardless of what, if you love horror movies or like horror movies, let me try that one more time. Love and hate. So people who love horror movies and people who hate horror movies report approximately the same level of fear. There is no difference between the lovers and the haters. All right, let me try and get rid of that box there. Now, the one comparison we have not made is like and hate. So we look at like and hate, we go across here until we get to the sig value, and we see that it is significant. So that tells us that we need to look at our means. We're going to have to report the direction of the effect. And so looking at the means, and I know what they are, I'm not going back to look at them, but I can now report that people who hate horror movies report significantly more fear than people who like horror movies. All right, so we've now looked at the Posthoc test for both factors. I want to now show you a picture of the interaction effect. So over here, well, along the y-axis, these are the fear scores. And along the x-axis, one is the daytime fear scores, and two are the nighttime fear scores. And then the different color bars, blue represents people who love horror movies, red is like, and green is hate. Now, when you interpret a two-way interaction, you can interpret it either by saying A depends on B or B depends on A. If I want to put that in context of this particular study, I could say, for example, the effect that horror has on fear depends on if you look at day or night. Alternatively, I could say the effect of time of day, so day versus night, on fear depends on whether you love, like, or hate horror movies. Both are correct ways of expressing the interaction, but I usually will choose one way. I won't choose to interpret it both ways. Usually that's redundant. So just by visual inspection, if we want to see what's going on, first we'll just look at the effect that time of day has on fear scores. We can see that during the daytime, if we look at the different horror movie preferences, we see that there really is no difference among the horror movie groups during the day. So here the effect that horror movie has is about the same. On the other hand, if we move over here to the fear time of day, so here's night fear, we see that there is a big effect of the horror movie factor. All right, here, if you love or hate horror movies, your fear scores are very high relative to if you just like them. All right, so here the effect that horror movie has depends. During the day, there's no effect. and at night there is an effect. If we wanted to look at it the other way, if we want to look at the effect of time of day on fear scores and know whether or not the effect of time of day is different for the different horror groups, we would compare, let's see, love to love. So we're going to look at time of day, but just for the love group. And we see that there is an effect of time of day for this group. In fact, nighttime fear scores go up dramatically. Is there an effective time of day for the like group? And the answer is no. If we compare like to like, they're approximately equal. And then finally, we're going to look at the hate group, ask, is there an effective time of day? And we see, yes, there is. Their fear scores go up from day to night. So again, both ways of looking at the interaction are fine. In another video clip, another tutorial, I'm going to show you how to further analyze the interaction. So if a visual inspection of the graph is not enough, there are tests that we can run to find out exactly what is going on with the interaction effect. These are called tests of simple main effects, and I encourage you to watch that video. Thanks for watching.